Okay, final video for this section. We're looking at two more problems here, 39 on page 759, and then later on 41 on the same page. So use the sum of the first 10 terms. So we are asked to find S10. To estimate the sum of the series, and the sum of the series n equals 1 to infinity from 1 over n squared, which we know is convergent. How do I know? Well, here's how we know. Oops, I didn't put my pages in order. Okay, here's what we know, because it's a power series or P series, and it's convergent for n equals n greater than 1, for P greater than 1, so that's what we have. We have 2. So we know that this is convergent. Okay. So they're asking us to estimate it using S10. So that's part A. And here we know that our f of x equals 1 over x squared. Yes, it's continuous. Yes, it's positive. And yes, it's decreasing. All conditions are fulfilled for the integral test. Good. So now we can directly determine S sub 10 using the calculator. And here's the sequence, the sum of the sequence, the syntax. So sum sequence, it's 1 over n squared. N is the variable. We start at 1, we end at 10, and 1 is the increment. So when I calculated this, please watch the video that we have in the previous section on how to use the graphing calculator to determine this, and I have 1.549767731. There is no need for all these decimals, but I just copy them down for you. Okay, so in order to, in part, was it part B? So how good is this estimate? So we're not in part B just yet. So we want to determine R sub 10. So we're not in part B yet. So we want to determine R sub 10, or R10, which is S minus S10. So if you remember from the beginning of this section, we have this estimate. So the integral from 11 to infinity from f of x dx is less than or equal to s less than or equal to s sub 10 plus the integral from 10 to infinity from f of x dx. Okay, so now let's calculate just the general, the integral from n to infinity from f of x dx. So let's see what we get. So definitely this is the limit as t approaches infinity from n to t, from x to -2. Whether there is no need, I can directly write -1 over x. So just in case you don't remember that, I put it in a different form for you. So t approaches infinity. So this is -1 over x from n to t. So this is limit as t approaches infinity from -1 over 10 plus 1 over n. This approaches 0 when t approaches infinity, so the answer is 1 over n. Coming back to our formula here, then I know that this piece is 1 over 10, so obviously by comparison this, or simply looking at 1 over n, so if this is 10 and I get 1 over n, which is 1 over 10, this must be 1 over 11. So definitely the error, right, R10 is definitely at most 1 over 10, 1/10. So we are aware of that. Now in part B. So we finally get to B. What is it? So it says improve this estimate with n equals 10. So here, in order to improve the estimate, so I replaced S sub 10 in this error formula, or approximation for the sum of the series. So we have 1. But you have all the entire number, but I'm going to write just 1.5498 plus 1 over 11, and the other side is 1.5498 plus 1 over 10. So what I got here was 1.640677 less than or equal to the exact sum, 1.649768. Now, when we average these two, add them up and divide by 2, so add them up, add them, and divide by 2, I got 1.64522. Okay, so now if you subtract the average from each, so 1.640677 minus 1.64522, and from the other one, 1.649768 minus 1.64522, you will get negative 0.0045 and 0.0045. So the max error is 0.005. Okay. In part C, so this is my page 12. In part C, they want us to compare pi squared over 6 from a previous problem, which we don't have to do anything, the number is given to us, and which I approximated it to be 1.644934. And the error from, and what we got was 1.64522. So when you subtract these two, you get negative 0.00028 such and such. So obviously the difference is less than 0.0003. Okay, and finally, in part D, they want us to find a value of n that will ensure, okay, so if the error has to be less than 0.001, they say, then we have 1 over n less than or equal to 0.001. So obviously, n has to be greater than 1,000. Okay, so the final problem I would like to look at is 41. And that is on page 759 as well. They want us to find or estimate the following infinite series, n equals 1 to infinity, from 2n plus 1 to negative 6. They want us to estimate it correct to 5 decimal places. So let's take a look at, so it's continuous, it's decreasing definitely, and positive. So let's take a look at the integral from n to infinity from 1 over 2n plus 1 to the 6th, of course, x dx. Okay, I should have written the function, okay, so you know where this is coming from. So this is 2x plus 1 to the 6th. Okay, so first I use change the improper integral into a limit. So limit as t approaches infinity, n to t, 1 over 2x plus 1 to the 6th dx. Yes, I'm going to use a substitution, 2x plus 1, du equals 2 dx. You know the trick. So 2 1/2. And from here, I'm going to jump over this to page 13. So we have 1/2, limit as t approaches infinity. So the integral from, so du over u to the 6th. So we have here 2n plus 1. And we have here 2t plus 1. So this changes into 1/2, limit as t approaches infinity. u to negative 5 over negative 5 from 2n plus 1 to 2t plus 1. Good. So negative 1/10, and we have limit as t approaches infinity. 1 over 2t plus 1 to the fifth minus 1 over 2n plus 1 to the fifth. So when t approaches infinity, all this term approaches 0. So the answer is 1 over 10 2n plus 1 to the fifth. So we want this to be, so 1 over 10 2n plus 1 to the fifth power. We want this to be less than, so 5 decimal places means 5 decimal places means 0.00000, anything 5 or above, because only 5 or above will change to the next. So it could be 5, it could be 6, it could be 7, 8, or 9. So that's why we have to start at 5. So this is basically 5 divided by 10 to the 6th. So that's why we want to make sure that the error is less than 5 decimal places. So we have to start at 5. If you put 4, that's not good enough. It's 5 or above for 5 decimal places. Okay? To change this into the next one. So 5 is here, the position for 5 decimal places. So then this has to be 5 or above to change this. Okay, so I'm going to try to solve this inequality for n. And that should give us what? The number of terms that we need for our sequence in order to approximate the sum, the total sum of this series based on having 5 decimal places approximation. Okay, so let's see how we solve this inequality. So first I'll multiply both sides by 10. Then I will cross multiply, so I have 10 to the fifth over 5 less than or equal to 2n plus 1 to the fifth. So what is 10 to the fifth? 10 to the fifth divided by 5. What will that be? 20,000 less than or equal to 2n plus 1 to the fifth. And now I will apply the fifth root to both sides because both of them are positive. Otherwise, I can't because it's the odd index. I can't. Okay, but keep in mind for the even indices, that's not allowed. So then we have 2n plus 1 greater than the fifth root of 20,000. Then I subtract 1. Then I divide by 2. So when you calculate this, what I have is 3.12, so n must be 4 terms. So we will approximate, correct to 5 decimal places, this sum from n equals 1 to infinity, 2n plus 1 to negative 6 by 4 terms. What do we have with 4 terms? 2 plus 1. So this will be 1 over 3 to the 6th. The next term, 1 over 5 to the 6th. The next term, 1 over 7 to the 6th. And the last term, 1 over 9 to the 6th. And the approximation, please put it in the graphing calculator as we discussed. I got 0.001446. As you see, it will be with 5 digits accuracy, 0.00145. thank you. I hope this helps. See you in the next section.